Hello everyone, my name is Momo Omotosho, and today we're going to be continuing with algebra. And the topic for this part is going to be linear equations. Linear equations. And I guess from what we've been talking about previously, we understand equations to be, I guess, the equality between two things. And we'd like that equality to be true. For example, if you have 2 equals 2, it's a true equality. And linear just refers to the fact that the variables that are in our equations are going to be only to the power or maximum to the power of 1. So there's not going to be any x squares or x cubes. It's just going to be x's and y's and variables like that with a power of 1. So I guess the first thing we could talk about when looking at linear equations is like the general form of, I guess, the most common form for linear equations, which is when equations look like this. We have, let's say we have y equals 2x plus 3. So right here we can see this equation has two variables. We have y and x. We have a coefficient for the x, and we have plus 3 on the right side of the equality. So basically what this equation is telling us is that we have our variable x, and depending on what we put in for x, y will change, y will vary. So let's say we put in x equals 1. Then our equation becomes 2 times 1 plus 3, which is 2 plus 3, which is 5. So then we have that y equals 5. So yeah, that is a big idea of linear equations. We have two variables sometimes, or like a lot of the times we have two variables, and depending on what we put for one of them, the other variable changes accordingly. And also it's very useful to be able to graph these equations. So let me draw a quick graph right here. We can go 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then this way as well, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Negative 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have our graph that is roughly 10 by 10. And with this, we want to graph this linear equation. So what we can do is we can, I guess, keep a table of different values that when we put into one variable, we get for the other variable. So what I mean by that is, let's have this table of x and y. And we already saw when x equals 1, right here, y equals 5. So we can put that in our table. When x equals 1, y equals 5. And that's, sorry, let me label my axes. It's good practice. I'll do it in a different color too so it stands out. This is the x-axis and this is the y-axis. So when x equals 1, right here, y equals 5. 1, 2, 3, 4, 5. So the intersection of that is right here. So that is a point that is relevant to our linear equation. We could also try when x equals 0. What happens when x equals 0 in our equation? We have y equals 2 times 0 plus 3. 2 times 0 is just 0, so we have y equals 3 when x equals 0. And we can mark that again on our graph. Let's also note that here. When x equals 0, y equals 3. 1, 2, 3. So right here. Now, for linear equations, to make a line, you only need 2 points. 2 points is enough to make a line for a linear equation. You can have as many points as you want, but you only really need to have 2 points to make your line. So since we have 2 points, we can go ahead and try to draw a straight line through these 2 points. Obviously, you should use a ruler if you have one. But I am drawing on my iPad, so this is good enough. And let me show you what I mean by you only need 2 points. Let's say we have x equals -1. In that case, we have y equals 2 times -1 plus 3. 2 times -1 is -2 plus 3, which is... 2 times -1 is -2 plus 3, which is -1. Sorry, it's +1. Yes. 1. So, if we look at our graph, when we go to -1, y is around 1. That would be if I drew the line better, you could see clearly that that at x equals -1, y equals 1. But that's what I mean by you only need. That's what I mean when I say you only need 2 points to define a linear equation, because then all the rest of the points in the equation will just fall on that line. So yeah. Also, with linear equations, it is good to know when you have a solution, or what points are solutions to linear equations. And the points that are solutions, or the points that are solutions to linear equations are just the points that fall on the line of your linear equation, and that make the equality true. So again, let's go ahead and look at a point. Or let me first go ahead and write out the equation when x equals 2, let's say. So we have 2 times 2 plus 3. Remember what our equation was. Y equals 2x plus 3. So we have y equals 2 times 2 plus 3. So 2 times 2 is 4 plus 3 is 7. So that means a point that makes this equation true is when x equals 7. It's when x equals 2 and y equals 7. So that point makes our equation true. And we could also see this by going to our graph and looking when x equals 2. We go up and we see that y is almost 7. Again, if I drew my line better, it would lie exactly on the line. If you use the ruler, you would see that. But yes, indeed, we can see that when x equals 2, y is about 7. And it's exactly 7, actually, when you look at the equation. So yeah, that is what it means for a point to satisfy the equation or to be a solution. When the point makes your equation to be true, and when it makes the equation true, it also lies on the line that describes your equation. So that is linear equations. I hope you guys found this video useful, and please come and watch my next video. And yes, thank you for watching.